In this video, we will talk about two instructions. That will be jump and loop. So the first thing we will see the jump instruction. So that will be jump to a code label. So the same thing, loop will be jump to a code label as well. But one thing different is jump is unconditional jump, but loop we have some condition. So the first thing we see jump. So jump instruction is an unconditional jump to a label. So of course here the label is code label. So that's usually within the same procedure. So that's the syntax. When you do the jump, right, you follow by the code label. So this code label will make the instruction pointer to go to that location. So for example here, we have the top is the code label because you see they have column. So when you jump to top, so they will know this top actually is the code label. They contain a memory address. So when we jump, we just direct jump to this location. Actually, that makes the instruction pointer to go here to continue to repeat the instruction. So you can see jump actually is what? Is unconditional jump. So that's why if you jump to the earlier, they will continue to instruction, then they will jump again. So if the jump to the to the location before that jump instruction, they kind of make the endless loop. So that's why sometimes jump actually we just jump to the afterward. So they will skip couple statement. But if jump to before your instruction, the code label is before your instruction, they will produce the endless loop. So that's the jump. So jump may reproduce endless loop. So on the other hand, we have another instruction we call loop. So the loop actually similar to jump. They will still is the loop. When you see the loop, they will go to your target code label. However, the loop, they will jump to there with some condition. So the condition is every time when you see the loop, right, before you jump to that code label, the logic is they will do a couple things. The first thing, they will decrement ECX by 1. So here you see it's only ECX. So when we do the loop instruction, ECX is automatically by default is the counter. So the ECX is automatically used as a counter and is decremented each time when the loop repeats. So whenever we see the loop, before I jump to that location, code location, the first thing we will decrement ECX by 1. Then we will check. If ECX not equal to 0, then I jump. On the other hand, if ECX equal to 0, then I just don't jump. I just continue, go to the next instruction. So that's how the loop instruction they will work for these two steps before you jump to the target. So how that happen, here we show you the implementation. Remember how you will go to that code label actually is we know the relative offset. The assembler actually calculate the distance in bytes between the offset of the following instruction and the offset of the target label. So then they call this one is relative offset. So the relative offset add to EIP, so instruction pointer know where to go. So you don't have to really know this one because this one actually you only see the information from the listing file, but that's actually good to know. So here we're just using the loop instruction, the two-step. We will see the example for the loop instruction. So we see here, that's a loop instruction. We see the source code first. So we see the source code only. So that source code actually, the following loop calculate the sum of the following integer. We start from 5 plus 4 plus 3 plus 2 plus 1. So then we have the sum saved in the AX. So then what that happened, right? Because the AX will be the sum, right? So remember, just like C++, you will make the sum initialize the value equal to 0. So then before you do the loop, okay, so you need to remember your ECX by default is the counter. So how many times you want to do, you need to move the value to ECX. So since I want to add from 5, 4, 3, 2, 1, so then I need to do 5 times. So after I move ECX with the 5, so now you see here, every time I just add the value to AX. Because the reason is I make the sum is AX. I still make the ECX value for the counter. But then here, since I have 5, right? So I'm using this 5 to add 5, 4, 3, 2, 1 to AX. So then because we save the sum in AX, so we just read 2 bytes from the ECX. So that will be CX. So after you're done, right, you see here, you need to repeat to add this one. So after you first time you move you add the 5 to AX. So the next one you want to do 4. So then since the loop instruction automatically, the first thing they deduct ECX by 1. So that's why here in the loop, they will decrement ECX. So the other thing is you just need to go back to where we add. So then we add the CX to AX. So the first time when they jump to the L1, see here L1 will be the label. When they jump to L1, the ECX will be decrement become 4. So again, I add the 4 to AX. So then again, before I jump, I decrement CX become 3. So then when I jump to L1, so 3 add to AX. So again, loop again. So then we will decrement to 2. So 2 add to AX. So again, 2 will decrement before they loop. So they become 1. So 1 add to AX. So then the loop will decrement ECX again, become 0. But the 0 is not. So because only ECX not equal to 0, we jump, right? So now ECX equal to 0, so they don't jump. They just do the next one. So that's how the loop instruction will do. So that's why here, when I show you this one, on this one earlier we told you. So earlier we said how the loop can jump to L1, right? So actually the L1 is a code label. So that's why they will have the memory location start from here. So then loop instruction, actually they just remember, supposedly if you don't jump, you will go to the next memory location. But now since you want to loop, right? So they will calculate this loop instruction location from the code label. So that's why you can see here, you will have your 9 minus C become FB. So then if they want to loop, right, they just from this current location plus FB, because that's a relative offset. So they know how to jump to L1. So that's a jump example. See, if you have any question, don't forget, make sure to write it down so I can answer your question during the Zoom meeting. So that's why here you will see the relative offset will be saved in 1 byte, right? So that's why if the relative offset is enclosed in 1 single sign byte, so that's why the largest possible backward jump, because for jump and loop the same thing, because the relative offset is only in 1 byte. So if they can backward, that means you see the backward will be the offset you need to add negative, right? So that's why the greatest backward is negative 128. But move forward for the jump will be the positive 127. So that's the relative offset mean. So make sure you understand the loop instruction and the jump instruction. So in order to make sure you understand that, so I want you to don't just see the 2 examples. So pause the video. So you just see this example and to tell me what is the final value in AX. So the same thing, AX start from 6. So ECX is 4. So we do 4 times. So every time we increment AX, right? So after we increment AX for 4 times, what the AX will be? Right, so the AX result will be 10. Okay, so this one is straightforward, right? So now here, actually, if that in the class, I will ask you guys to do the group chat. So this one is, I want you to tell me how many times the loop will execute. So do not see the answer, you just see like this. So the same thing, I move AX with the 6. I have ECX, but I start from 0. Okay, so I have my code label is X2. So every time I increment AX, so then we loop. So actually, how many times they will run? Okay, we need to be careful. Your ECX originally equal to 0, right? Okay, so remember, I increment AX. So now before the loop can jump. So here you need to be very careful. Every time when we do the loop, right? They decrement first. Then they check ECX not equal to 0, we jump. So that's why here, ECX equal to 0. But when you do the loop, ECX will do what? Decrement by 1. But decrement by 1 actually is what? Yeah, it's not -1. Or you can say -1. But -1, how they interpret into 4 byte, that's the ECX value is. So even we say 0 minus 1 is -1, right? But ECX is unsigned location. So they will have -1, but in ECX, they translate as the unsigned integer. So that's why actually become very big number. So then actually how many times they will loop execute? They will become 2 to the 32 power. The reason is when you have decrement by 1, your ECX is actually that big. Because remember, ECX is 4 byte. So the greatest value for 4 bytes is this one. So then you see they jump to here, right? Good. So then continue increment AX. So I loop. So I decrement ECX. So then ECX not equal to 0. Okay, I jump again. So honestly, for this example, be careful. ECX start from 0 doesn't mean they won't loop. Instead, they will loop many, many times. So that's an interesting example. Make sure you understand how to do that. So that's our loop and jump. So later we will see the example on how to use that in the source file.